absorption and metabolism of vitamin B12. In foods, vitamin B12 occurs in its free form as well as bound to protein. Free vitamin B12 is bound to saliva glycoproteins, so-called R proteins. Protein-bound vitamin B12 is released in the stomach due to acidification, as well as by enzymatic degradation of the proteins, especially by the action of pepsin. Thus, impaired gastric acidification, as in achlorhydria or with chronic use of antacids, impairs vitamin B12 uptake. The released vitamin B12 is then bound to the R proteins, also secreted by the stomach and upper small intestine. The activity of the enzyme trypsin, secreted by the pancreas, releases the vitamin B12 again in the upper small intestine, and it finally binds to a protein produced in the stomach called intrinsic factor. Once in the ileum, the lower part of the small intestine, the vitamin B12 intrinsic factor complex attaches to specific receptors present on the intestinal cells that facilitate its active absorption. Passive diffusion only occurs at high concentrations. In the intestinal cells, vitamin B12 is bound to transcobalamin 2, a specific binding protein that carries vitamin B12 through the bloodstream. Cellular uptake occurs through a receptor-mediated process that recognizes the transcobalamin 2 protein. The liver converts vitamin B12 into its active coenzyme forms. The liver also stores 60% of all the body's vitamin B12. Some of it is continually excreted via the bile, but then comes back to the liver after absorption via the so-called enterohepatic circulation.